All right, let's dive into something that makes our entire digital world tick. Today, we're talking about how computer networks went from basically shouting at everyone all the time to the incredibly smart, efficient system we couldn't live without. To really get this, just picture it for a second. Every single letter, every package, every bit of junk mail from your entire town gets delivered to your mailbox. You'd be drowning. All your time would be spent just sifting through mountains of other people's stuff to find the one letter that's actually for you. Well, believe it or not, that's exactly what early computer networks were like. And the villain in our story, the source of all that digital shouting, was a simple device called a hub. Hubs created a world of constant network noise, where every computer had to listen to every single conversation happening on the network. Just chaos. This slide just lays it all out perfectly. Over here on the left, you've got the old way with hubs. It was a total mess because it sent every single piece of data to everyone. This created what we call a collision domain, which slowed everything down to a crawl. On the right, well, that's the promise of a much smarter way, which we're about to get into. So, why were hubs so, well, dumb? It's because at their core, they're just multi-port repeaters. That's the technical term. All it really means is they don't think. A signal comes in one port, and the hub just makes a copy and blasts it out of every other port on the device. It has no idea who the message is for, and frankly, it doesn't care. Let's really lock in that term, collision domain. The analogy here is perfect. Think of a big, busy intersection, but with no traffic lights and no stop signs. The data packets are the cars, and they're just flying through and constantly crashing into each other, causing these massive digital traffic jams. But, of course, every story of chaos needs a hero to bring order. And for us, that hero is the network switch. It's the smart traffic cop our network was desperately waiting for. So what's the big difference? Unlike a hub, a switch actually has a brain. It's a specialized little chip inside called an ASIC, and its entire job is to learn. It builds a map of the network, figuring out exactly which device is plugged into which port. So how does this brain actually build that map? What's the secret? Well, it all comes down to one critical component, the MAC address table. Now, before we get to the table, we have to know what a MAC address is. The easiest way to think about it is like a permanent fingerprint for your gear. Your laptop, your phone, your smart TV. Every single device that connects to a network has a unique MAC address that's burned in at the factory. It can't be changed. And this is what the switch does with those fingerprints. The MAC address table is basically the switch's internal address book. It's a super simple but incredibly powerful list that just maps a device's unique MAC address to the physical port it's plugged into. That's it. Okay, this is the really cool part. A switch isn't born smart. It doesn't come out of the box knowing anything. It has to learn. So let's watch how it goes from a completely blank slate to a networking genius. The whole process is brilliant. So first, a switch powers on for the first time. Its table is totally empty. Then a computer sends out some data. The switch takes a peek at that data, specifically at the source MAC address, and has an aha moment. It says, okay, so that device lives on port 1. It jots that down in its table. And from that second forward, any data meant for that device gets sent only to port 1. The shouting is over. And here's what that blank slate looks like in the real world. This is the command a network admin would type into a brand new switch. And the output? Nothing. The table is completely empty, a blank canvas, just waiting to learn about its new neighborhood. Now check this out. This is one of my favorite little nuggets from the source material because it shows you the learning happening in real time. A technician sends 5 little test packets, called pings. You see 1 period, then 4 exclamation marks. That single period represents the first ping, and it failed. But why? Because in that split second, the switch didn't know where to send it. But in the process of shouting it out one last time, it learned. And the next 4 pings, perfect success. That 80% success rate isn't a failure. It's the beautiful sign of a switch learning its job. And here is the result. This is the aftershot. The admin runs the exact same command again, and just look at that. The MAC address table is now populated. The switch knows that one device is on port FA0/1 and another is on FA0/2. The network is now officially smart. So we know how a switch thinks, right? But what does it actually take to get one of these things up and running in a real network? Let's take a quick peek at the basic setup. So, to get a new switch working, an admin will do a few key things. They give it a unique name so they can tell it apart from the others. They assign it a management IP address. Think of it like its phone number so they can talk to it. They also have to tell it where the exit to the bigger internet is. That's the default gateway. And finally, they'll enable secure remote access so they can manage it safely from anywhere. So, what's the bottom line here? Switches are the undisputed masters of the local network. They're like hyper-efficient mail carriers for a single town. But what happens when your data needs to go to a different city or even a different country? How does it cross oceans and continents? Well, that is a job for a completely different device. And that's a story for another time.